Okay, so today we are looking at Venn diagrams. That's going to be the first thing we're doing. And a Venn diagram represents the sample space in a rectangle. And what we're going to do then is we're going to be able to sketch a rectangle. And every single rectangle we use for Venn diagram, we're going to use this letter U. It's kind of a diagonal letter U. And I don't want you to be confused when we're talking about the union symbol, which is also a letter U. That looks a little bit different than this one. All right, but for our Venn diagram in a class survey, we're going to look first at Ricardo, Melina, Daniel, Maria, India, and James. They reported that they study environmental systems and societies, ESS. Okay, and we're going to represent that on our diagram with the letter E. And then we have India, Pietro, Mathia, and Hannon, and they said they were studying geography. So those guys are studying geography. And then we have Ricardo and James, who are the only ones that reported that they were studying Spanish. And then Sophia and Julia studied none of the subjects. So what we're going to do with our Venn diagram, we're going to create some circles here. And we'll call this circle will be our E for the environmental stuff. Which I'll do it with red, so we stick with the color. And then we had another one that was going to be, yeah, let's do this. There we go. So red, that was our E circle. We had the blue one, which was our geography. And then we have yellow, which represents James and Ricardo, and they also happen to be the only ones that are doing Spanish, and they're both in the environmental studies as well, so we're putting S there for that one. And then Sophia and Julia didn't do any, so we're just going to put them outside. Sophia, Julia go out here, and then we put the rest of the names inside their respective circles. So we've got Ricardo, he'll go inside the Spanish circle, which is inside the other one, and so will James. And then we have India that's doing both, so we'll put her in here. Okay, so that takes care of India, Ricardo, and James. Let's see. And India is the only one that's doing both, it looks like. Now we're going to put Melina in here. She's in the ELA class, or ESS class. And Daniel's in the ESS class. And then the last one's Maria in the ESS class. I did not leave myself a lot of room here. So hopefully you make yourself a bigger circle. Now for the kids that are taking geography, you have Pietro, Mathia, and Hannon. And really important when we're creating these lists, we want them to be accurate, because now when we get to the next part, we will be able to do it very quickly. And when we're talking about the probability that someone studies ESS, the way we think about this is we'd say, oh, the probability of, we're using the letter E for ESS. We're going to say the probability of E is going to be the number of E over the number of U. And remember, U represents our entire data set. So in this entire data set, there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 students. That's where the 11 comes from. The ones that studied ESS, there were 1, 2, 3, 4, 5 students. So the probability turns out to be 5 out of 11. Oh, actually, I'm sorry, I forgot about India. She was in the circle with the geography as well. So there were 6 students, and I could actually count that up top. 1, 2, 3, 4, 5, 6. Yeah. Okay, perfect. So 6 students that go on the studies ESS. Now, studies ESS, but not Spanish. They're going to be 4 out of 11 of those ones, because that's everybody except for Ricardo and James. Then there's someone that studies all 3 subjects. That's a 0, because Ricardo and James are the only ones that study Spanish, and they don't study geography. And then the last one studies exactly 2 of the subjects. So Ricardo and James study 2 subjects. India studies 2 subjects. So that's going to be 3 out of 11 of the total students study 2 of the subjects. All right, that's how you would use a Venn diagram to help you quickly analyze everything. But the really important part is that you get that Venn diagram drawn accurately at the very beginning. That's what's going to make you successful in answering the rest of the questions from there. And some of the times the notation can be a little bit tricky. That's what we're doing here with the probability of the event happening. And that's the number of the event over the number of the total sample space. Those are just some quick things to remember about that. All right, let's move on to example 6. It says in a class of 26 students, it is found that 10 study geography, 16 study history, and 4 study neither history nor geography. Calculate the number of students who study both history and geography. So the first things first, it's saying there's 26 students total. Now, if I were just to do my math real quick, I could see there are 10 that study geography and 16 that study history. And then 4 that don't study either. That comes out to 20, right? 20, that comes out to 30, sorry. So that's more than 26 students. So that's a little bit of a problem for us because there should only be 26 students. That means there's some overlap of these 10 and 16. Some of them are doubling up, they're studying both. So what we're going to want to do is we're going to want to figure out how many are studying both. So we'll create our U, our sample space. We're going to start by creating a geography class, and then we'll add another circle that represents the history class. And we're going to put 4 out here. There are 4 students out there. Now, in geography, there were 10 students that studied it, but there were also some that are going to fall into the middle ground right here. So we're going to say 10 minus x are in the rest of this circle. On this one, we can say 16 minus x for the history class. All right. So we know there are 26 students total. And there are 4 of them that aren't studying either subject. So we're left with 22. Now I can say 22 equals 10 minus x plus 16 minus x plus x. The number that should be in the middle should just be an x. That's what we're doing, 10 minus x and 16 minus x. They're sharing that value in the middle, which is an x. And we should simplify that. We should get minus 2x plus 1x, so we're going to get a minus 1x. So we end up getting 22 equals 26 minus x. If I add x to both sides and subtract 22 from both sides, I end up getting x equals 4. A little tight on space there. So this ends up being a 4 there, which means if I redid my numbers, this would be a 6, this would be a 12, and this number would be a 4. And now all of my numbers should add up to 26. I should have 6 and 4 is 10, plus 12 is 22, plus 4 more is 26. So that totally works out, which is good. Then it says, find the probability the student selected at random from this class studies exactly 1 subject. All right, so there were 6 that studied geography, 12 that studied history, and there were 26 students total. So the odds that you pick someone that studied history or geography is 1826, but they didn't study both, just one of them. And that simplifies to 9/13. So that's how you'd find the probability that you studied just 1 subject only. All right, so that covers problem 6 there, example 6. Now the other part of today, we're going to talk about a sample space diagram. And what a sample space diagram is where we create a diagram that shows all of the possible outcomes. So on this one, we have this pair of Shisherman dice is thrown, and 2 of the numbers obtained added together. The probability of each is just the same as if 2 dice were rolled numbers 1 through 6. So standard die, the 1 through 6 die we're used to seeing. So what we're going to do is we're going to verify this claim. So we'll start with the standard die, standard dice roll. And we'll create this table. And we're going to say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And we have to create a bunch of columns here. A lot of columns. And when we create all of our columns, we're going to add the sum of each dice roll outcome. I'm going to change colors for that. So for example, if we had, oops, I need the red one again. So if we had 1 plus 1, that's going to equal 2. And then 3, 4, 5, 6, 7. Going this way, 2, 3, 4, 5, 6, 7. And then 2 plus 2 is 4, 5, 6, 7, 8. And then 5, 6, 7, 8, 9. 6, 7, 8, 9, 10. We'll just fill this whole thing out as we go across. 8, 9, 10, 11, 12. So that's the standard dice roll. And one important thing to remember, standard dice roll, it's always going to be 36 possible outcomes every time you roll 2 dice. And this is the list of all 36 possible outcomes. That's what the sample space diagram is the list of all 36 outcomes. Now, this other die, it's called the Shisherman die. They have these 2 sets of numbers here that I've written down. That's what their 2 6 sides look like. So if I were to create a similar box, all right, we'll do that. And we're going to say 1, 2, 2, 3, 3, 4. And the other side is going to be 1, 3, 4, 5, 6, 8. And then we'll go ahead and create all of our columns for this one. All right, so I'm going to go ahead and fill that in. I'm going to pause the video for a second, but I'll fill it in and it'll be populated. Okay, so I got the die populated now. And now, to verify this claim, you get the exact same rolls. We just have to look like, hey, there's 1, 2 here, and there's exactly one way to get 2 in this. So the outcome is 1 out of 36 for both. Then for the next one, we can say, okay, if I get a 3, there's 2 outcomes for 3 there, 2 outcomes for 3 there. And I just keep doing this and saying like, okay, to get 4, there's 1, 2, 3 possible outcomes for 4. There's 1, 2, 3 possible outcomes for 4. And verify all the way through, like, hey, there's 1 outcome for 12 only, whoops, and 1 outcome for 12 over here. And we can go through and we'll actually verify that every single one is true. Like, for example, 7, there should be 6 outcomes for 7. 1, 2, 3, 4, 5, 6. And then over here, there's 1, 2, 3, 4, 5, 6. So yeah, it turns out if we do check out all of them, that there will be the exact same possible outcomes in both pairs of die, even though one of them has an 8 on it and some weird numbers, and the other is a traditional 6-sided die. Now, example 8 says, use the sample space diagram from example 7 to find the probability that the total found throwing 2 Shisherman die is, and it says at most 4. So honestly, we could use this one right here, but since we know the probability is the same, and I'm more comfortable using standard 6-sided die, I'm just going to use this information here. And when it says at most 4, I'm saying, hey, there's 1, 2, 3, 4, 5, 6 possible outcomes for at most 4 out of 36. All right, which is a 1 in 6 probability that you're going to roll a 2 or 3 or 4. Then it says a factor of 24. Well, factors of 24 are going to be 1, but 1's not possible to roll. 2, 3, 4, 6, 8, 12, and 24 is not possible to roll. So those are the possible factors. So we have a chance of 1 getting a 2, Getting a 3, you have 2 possible options. Getting a 4, you have 3 possible options. Getting a 6, you have 5 possible options. Getting an 8, you have 5 possible options. And getting a 12, you have 1 possible option. That's out of your 36 total. So this ends up being 3, 6 plus 10 is 16, 17 out of 36 of your possible rolls. So slightly less than 50% there chance of getting a roll that's a factor of 24. And then the last one, at least 8. So again, I'm looking at my standard side die again, and I'm going to say at least 8 is going to be starting here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there's 15 possibilities out of 36. And I should be able to divide both 15 and 36 by 3. That's going to give me 5/12, just to simplify that fraction as much as possible. Okay, that's it for the lesson today. If you have any questions at all, please hit me up during office hours. The assignment is attached. Good luck on that.